Some basics then on circles, perimeters, areas, circumferences of different shapes. Fairly new for you this year then is circles, where we have to consider the diameter of the circle that should be going through the middle point here, and it's from one edge of the circle to the other, and the radius that is from the middle point out to the edge of the circle. So there of course is a relationship between radius and diameter, that diameter is 2 times what the radius is, or the radius is the diameter divided by 2. To work out the area of a circle, we use the number pi, which by the different experiments that you've done, we're using pieces of string and connecting to measuring the diameter of your circle and then trying to go around the circumference of your circle. Most of you worked out that pi was a little bit more than 3. 3.14 is pi to 2 decimal places. If you've got a question with calculators, you usually use pi as 3.14. But if you don't have a calculator, you can often approximate pi to be about 3. The area of a circle is defined as the number pi multiplied by the radius squared. That means pi times radius again. And the circumference of a circle is determined as 2 times pi times the radius, or that's the same as pi times the diameter. So these are the basic things we need to be able to work out the areas and circumferences of circles, and these formulas are super important. You should know them. They will be given to you on some of the national tests, but not on all of them. Okay, if we were to work out the area then of, here we have one semicircle, and we will call this radius here then 8 centimeters, and then the semicircle is split up into 2 smaller circles where the radius of the smaller circle is 4. If we were to measure the radius of the whole shape, we would have to measure the radius of the semicircle, number 1, and we'll call this one number 1, plus the area of circle number 2. And we can see that circle number 2 is actually 2 semicircles, which is 1 whole circle. So we would use our formula, pi r squared for circle 1, divided by 2 because we've only got half a circle, plus the area for pi r squared, where we've got r2. This is pretty easy to work out. We have pi multiplied by the first semicircle, 8 squared divided by 2, plus pi times r2 squared, which is 4 squared, and we don't divide by 2 here because we've got 2 semicircles. Let's leave it in terms of pi all the way through here. 8 squared is 64, divided by 2 is 32, plus pi times 4 squared, which is pi times 16. So 32 and 16 is 48. 48 what? 48 times pi. So we can actually keep it in this term, centimeters squared, because it's an area. Or we can use a calculator to get pi exactly. Or we can say, okay, we're doing this without a calculator, so we will use pi as being 3. 8 threes, 8, 16, 24. 3 fours, 12, plus 2, 14. 144 centimeters squared would be the area of this shape by taking it as 2 separate circles. To calculate the perimeter then, we would need pi times d1 divided by 2 because we've got a semicircle, plus pi times d2, and this one isn't divided by 2 because we've got a whole circle. Make a little bit more space over here. So d1 is 16, so we would have pi times 16 divided by 2 plus pi times d2, which is 8 centimeters. So look what we would get here. We would get 8 pi plus 8 pi. 16 divided by 2 is 8, so we'd get 8 pi plus 8 pi. So it would give us 16 pi. That's quite interesting, because isn't 16 pi what the circle would have for a perimeter if it was a whole circle? So I think they want you to try and realize that. Look, they're showing you something here, that if you actually split this semicircle up into 2 small circles down here, you would actually get the same perimeter as though you had a whole semicircle down in the bottom. So quite an interesting phenomena that I think they wanted you to investigate. What about when we've got triangles then? Well, we know that the area of a triangle is always base times perpendicular height divided by 2. And the reason I write this little symbol here for perpendicular height is that this 10 centimeter here, or this 7 centimeter, that can also be considered a height of the triangle, but it's got nothing to do with calculating the area. If you're going to calculate the area of a triangle, you need the perpendicular height. You need the 90-degree angle height between the base of this triangle here and the point opposite the triangle that you're trying to find out. And you have to make this imaginary line, and that's why it's dotted, because it's actually not part of the triangle, but it's essential to know what the perpendicular height is to be able to calculate the area. So to calculate the area of this triangle, I need to know what the base is, which I can see here is 3 centimeters. And notice I'm using the real base here, not this imaginary base that I've made here. That's only to help you draw the perpendicular line. Multiplied by the perpendicular height here that I've given you as 5 centimeters divided by 2. Well, we know that 3 5s are 15. Centimeters times centimeters is going to give me centimeters squared. Anything multiplied by itself is squared. And 15 divided by 2 is going to give me 7.5. So the area of this triangle is 7.5 centimeters squared. But I would need to know the length of these triangles, this 10 centimeter and this 7 centimeter, if I asked you to work out the perimeter. This vertical height doesn't help you at all if you're working out the perimeter of the triangle. So you would need, if I asked you then to work out the perimeter, then you need all the different lengths of the triangle. You need the base, 3 centimeters, plus the side number 1, 7 centimeters, plus the last side, 10 centimeters. So the perimeter of this triangle would be 20 centimeters, 3 plus 7 plus 10. And that's what you need the length of the triangle for, not for the calculation with area. There you need the perpendicular height. Okay, some basic shapes here. What have we got? Well, we've got a parallelogram here, we've got a rectangle, and here we've got a rhomb. Parallelogram means that these two lines are parallel. Parallel. I'm too near to the top here. Parallelogram. How do we work out the area of a parallelogram? Well, we use the area of the base, again, multiplied by, and again, we want the perpendicular height. We do not want this height on the side here. The length of the parallelogram we don't need. We need the perpendicular height to work out the area of a parallelogram, always. It's this height you need. The area of a rectangle, again, just base times, and because it's a rectangle, it means there's a 90-degree angle there, so you've already got the perpendicular height. And the area of a rhomb would be the base, and again, you need the perpendicular height here. Means you need the height where 90-degree angle connects to a point opposite. So we need the perpendicular height. The area of is the base times the perpendicular height for a rhomb as well. Remember the names of the shapes. So and our rectangle. Then we have a triangle. The area of a triangle is always the area of the length of the base times the perpendicular height divided by 2. And if you don't know the perpendicular height, then you have to drop down an angle here at 90 degrees and measure it. If they don't give you that, then you measure the perpendicular height. If they in a question say that the length of this triangle is 4 centimeters, the base is 6 centimeters, and the angle here is 60 degrees, then you can construct the triangle in your books, and you can drop down the perpendicular yourself, measure it with a protractor to get the 90-degree angle, and you measure the perpendicular height that you need, because it's that you need for the area calculations. So area equals length of base times the perpendicular height divided by 2. The most common mistake that I see is that you forget to divide the area of the triangle by 2. You've got to imagine that a triangle is like half a square, half a rectangle. So it's super important to remember that. Then we've got arcs of a circle. How do we measure, using our math skill, how much of this circle of my arc is here? Well, what we need to know is that we know that the circumference of a circle, or perimeter we use sometimes, but we call it circumference, but sometimes I use the symbol P, is pi times d. But that's for the whole circle. So the whole circle in this case would be pi times 40. I've said that the radius is 20, so notice that I need to convert that to diameter. So the whole circle would be pi times 40, but I'm saying that I'm not using the whole circle, I'm using a fraction of it. How much am I using? Well, I'm actually using 30 degrees out of how many degrees are in a whole circle? 360. Okay, and what is that? Divide top and bottom here by 3, cancels the zeros. So I'm using 1/12. So I want to know what 1/12 of this circle is, and the circumference of 1/12. Well, then I will do that. I will divide the C of the whole circle by 12, which would be 40 pi divided by 12. That would give me the perimeter of this arc, and that's how we work them out. Then we have trapeziums. How do we work out then the area of a trapezium? And a trapezium is that one length is different to the other, so you have one set of parallel lines. These lines down here are parallel, the arrow means parallel, but the vertical lines are not parallel. Well, they're not vertical, but the ones going upwards are not vertical, are not parallel. The area of a trapezium is always calculated as A plus B, the length A plus B halved. Half of this length plus this length would be equivalent to an average of the base, multiplied by the vertical height. So what we need to do is we need to get an average of the base by adding these two very long ones together, half it to get the average, and then just multiply by the perpendicular height. So very similar to a parallelogram. And then the only other one is a rhomb. If we don't know the perpendicular height of a rhomb, which we can also get, we can actually work it out using the diagonals. The area of a rhomb can be taken by multiplying diameter 1 times diameter 2 divided by 2. So that's a formula for working out the area of a rhomb. Okay, in case you don't have this perpendicular height here. You don't actually need it because there is another way to calculate the area of a rhomb. D1 multiplied by d2 divided by 2. And here we've got, yeah, looks a bit square-like, this wrong that I've drawn, I apologise for that. This angle is slightly less than 90 and this is slightly bigger than 90. But anyway, you understand the principle for calculating the area of a ROM.